Hello, in this lecture I will prove the Pythagorean theorem. The Pythagorean theorem relates to a right triangle. A right triangle is a triangle in which one of its angles is 90 degrees. This angle is 90 degrees, so it is a right triangle, and the Pythagorean theorem says that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars, or in mathematical notation is c square is equals to a square plus b square. Again, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars, or c square equals to a square plus b square. In order to prove the theorem, I made a copy of this right triangle in the left side of the picture. Actually, on the same line of B, I built the side A, so B and A is in the same straight line, and I raised a perpendicular in size of B to A. So the angle between side A and side B in the left side of the picture, in the left triangle, is 90 degrees. Okay, so actually we have here two triangles that equals in two sides. Side A in the right triangle equals to side A in the left triangle, and side B in the right triangle is equal to side B in the left triangle, and also the angle between side A and side B in the right triangle is equal to the angle between side A and side B in the left triangle. Both of them are 90 degrees. So we have two triangles that are equal in that has two sides that equal to each other, and also an angle between those two sides is equal to each other in the two triangles. Therefore, those two triangles are coincides to each other. Okay, and therefore this side is side C in the right triangle, therefore it must be side C also. This must be side C in the left triangle, because of the rule of corresponding sides in coincides triangles are equal to each other. So now suppose that we'll call to the angle between side A and side C in the right triangle, we will call it alpha. Then the angle in the left triangle, the angle between side A and side C must be also alpha, according to the rule corresponding angles in coincides triangles are equal to each other. Okay, suppose that we will call the angle between side B and side C in the right triangle x. We call it x because we don't know the size of these angles, but we do know that the sum of the three angles in every triangle in the world must be 180 degrees. So alpha plus 90 degrees plus x must be 180 degrees. We can write it down that alpha plus 90 degrees plus x equals 180 degrees. Okay, the sum of the angles in the right triangle, that is alpha plus 90 plus x, equals to 180 degrees. It is correct for every triangle in the world. The sum of every triangle, the sum of its angles is always 180 degrees. We can subtract 90 degrees from both sides of the equation. Then we will get that alpha plus x equals to 90 degrees. Okay. Now we can subtract alpha from both sides of the equation. So x equals to 90 degrees minus alpha. Okay, x equals to 90 degrees minus alpha. So now if we look at the middle triangle, we don't know what size is this angle between C and C, so we will call it Y. Okay, but we do know that in every straight line the sum of its angles in one side, for example in the upper side, is equals to 180 degrees, and so it is correct also the same thing in the bottom side. The sum of the angles in the bottom side of the straight line is always 180 degrees. So we can write it that x plus y plus alpha equals to 180 degrees. Okay. The sum of the angles of a straight line on one side, in the upper side, is 180 degrees. So x plus y plus, I made a mistake, sorry. So x plus y plus alpha equals to 180 degrees. The sum of the angles in the upper side of a straight line equals to 180 degrees. But we know that x equals to 90 degrees minus alpha, so we can substitute x by 90 degrees minus alpha. So 90 degrees minus alpha plus y plus alpha equals to 180 degrees, and minus alpha plus alpha equals to 0, so we can eliminate alpha from the equation, and we can write that 90 degrees plus y equals to 180 degrees. Ninety degrees plus y equals to 180 degrees. We can subtract the 90 degrees from both sides of the equation. So we will get that the angle y equals to 90 degrees. Okay, the angle y equals to 90 degrees. So the middle triangle is a right triangle because it has one angle that equals to 90 degrees. Now, as you can see here, we have a trapeze. A trapeze is a square with a pair of sides that are parallel to each other. Side A is parallel to side B because both of them have 90 degrees with side A, and this angle side A is perpendicular to side B, so A is parallel to B. So we will calculate the area of this trapeze in two ways, and then we will compare the result of the first expression to the second expression. Of course, they are equal to each other, and in this way we will derive the Pythagorean theorem. So we will calculate the area of this trapeze in the first way. We can say the area, we will call the area of the trapeze S. S equals to the sum of its parallel side, that is A plus B, times the height of the trapeze, that is also A plus B, all divided by 2. So the area of the trapeze is the sum of its parallel sides, that is A plus B, times its height, that is A plus B also, all divided by 2. Now we'll calculate the area of the trapeze in a second way. We can say that the area of the trapeze is actually the sum of areas of its three triangles. So the area of the trapeze equals to the area of the right triangle plus the area of the middle triangle plus the area of the left triangle. The sum of the triangles areas is actually the area of the trapeze, because the trapeze is composed of three triangles, and the sum of its areas is actually the area of the trapeze. So we would calculate the areas of the three triangles. The area of the right triangle is its base times its height to this base divided by 2. The base is b times the height is a divided by 2. So BA divided by 2 is the area of the right triangle, and the area of the middle triangle is its base times the height to this base divided by 2. So it is C times C divided by 2 plus the area of the left triangle. The area of the triangle is its base times the height to the base divided by 2. So it is, the base is A times the height is B divided by 2. So it is A times B divided by 2. So in total, the area of the trapeze is the sum of the areas of the three triangles that the trapeze composed of. Or we can say that the area of the trapeze equals to the area of the right triangle, that is B times C divided by 2, plus the area of the middle triangle, that is C times C divided by 2, plus the area of the left triangle, that is A times B divided by 2. So now we can compare expression 1 to expression 2. Of course they are equal to each other, because in both of the expression there is the area of the same trapeze. So we'll compare expression 1 to expression 2, and in this way we will create the third equation. So actually a plus b times a plus b divided by 2 equals to pa divided by 2 plus c times c divided by 2 plus a times b divided by 2. So in this equation, expression 1 equals to expression 2, or the area of the trapeze in the first way equals to the area of the same trapeze in the second way of calculation. So the area of the trapeze in the first calculation is the sum of its parallel sides times the height divided by 2, and the area of the trapeze in the first calculation equals to the area of the trapeze in the second calculation. In the second calculation, the area of the trapeze is the sum of the areas of its three triangles that the trapeze composed of. So it is the area of the right triangle plus the area of the middle triangle plus the area of the left triangle. The sum of the three triangles areas is the area of the trapeze. So we will multiply by 2 the two sides of the equation. So it is A times B, A plus B times A plus B, plus BA plus C plus AB. Now AB plus BA plus AB is 2AB, and C times C is C squared, so we write it down. So A plus B times A plus B equals to 2AB plus C squared. Now we will open the brackets in the left side of the equation. So A times A is A squared, and B times A is BA, and A times one minute. A times A is A squared, plus A times B is BA, plus B times A is BA, plus B times B is B squared. So here BA plus AB is 2AB, so we'll write it down. So we got A squared plus B squared plus 2AB equals to 2AB plus C squared. So we can subtract 2AB from both sides of the equation, and then we will get that the final result is that A squared plus B squared equals to C squared, or in other words, the square of the hypotenuse is equals to the sum of the squares of the perpendiculars. Okay, so that's what we wanted to prove. So we can summarize the proof and say that we add a right angle, and we want to prove that A squared plus B squared equals to C squared. So we made a copy of the right triangle here in the left side of the picture. Then we found the angles of the triangles. We found that the right triangle is also the middle triangle is also a right triangle, and we calculated the area of the trapeze in two ways, and then we said that the result in the first expression equals to the result in the second expression, because it is the same area of the same trapeze. And actually here the first expression equals to the second expression. Both of them is the area of the same trapeze. For that reason they equal to each other. And after we developed the equation, we got to the final result that says that the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. Okay, or c square equals to a square plus b square. Okay, thank you very much.